Okay, so this is the lecture in which we introduce Python. This assumes that, of course, that you know some programming language, and by now all of you know MATLAB pretty well. Um, if you know Python, of course, that's great. I do know that many of you do not have experience with using Python. So this is mostly an introduction. It is by no means an exhaustive or very systematic introduction to Python because that might be the content of a whole course. What we're going to do is quickly introduce things, talk about a few key language constructs, I guess, the syntax of the language and the general structure of the language, and in a manner that you're able to use the language for the things that you want to do for this course. Of course, if you want to do a much more detailed sort of dive into using Python, you might want to take a fully sort of Python course, say at Ohio State or online. There's infinitely many online courses that teach the Python programming language, so you might consider one of those things. I think on the syllabus, in fact, I refer to one or two of them, so you can consider that. Okay, so let me just very quickly overview the language. This is just the Wikipedia page on this programming language. If you're not familiar with, say, explicitly the properties of different programming languages and how they differ, it might be fun to read through one of these things. Maybe read some article on the differences between MATLAB and Python, or if you're familiar with C, maybe differences between those languages. Might be worth learning about these words, what these words mean. So Python is an interpreted language, as is MATLAB, which is different from languages like C, um, or Pascal, and a few other languages where uh, you write a program and the program gets compiled, which means it gets converted essentially to machine code, machine language, before where the computer can execute the code. Python is interpreted in that you write your statements in sequence, and uh, when the code is executed, at least in a purely interpreted language, um, the interpreter has not seen the next line when it's seeing executing the current line. So it sort of goes in sequence. Whereas in a compiled language, the compiler sort of takes into account the whole code in some manner and does some optimizations before it actually runs the whole code. Anyway, so that's interpreted. High level just means that it's not sort of machine language or assembly. Uh, it just means you give the computer high level instructions as opposed to very low level instructions. General purpose just means you can do a lot of different things, a variety of applications. The language is sufficiently broad and powerful that you can do a lot of things with it. It says Python's design philosophy emphasizes code readability, which is always very good, with notable use of significant white space. This word significant here doesn't mean a lot of white space. It actually means that the white space has significance in the language, as we will see, which kind of bothers me a little bit because I'm more used to languages where white space did not have significance. Um, Nevertheless, I guess it does make you or force you to have white space in certain spots, which actually makes language more readable. Anyway, so there's lots of, you can read the whole thing if you like. Here they talk about Python 2 language and then Python 3. The current version of Python, the support version of Python is Python 3, which is what we are going to use. Um, okay, so that's about the Python programming language. If you do a Google search, it goes to this website, which is the website of the Python Software Foundation, I believe. Um, in any case, there is plenty of resources there and elsewhere Um, documentation, blah, 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 beginner's guide. Okay, plenty of stuff, okay? Um, beginner's guide for non-programmers, programmers, beginner's guide specifically if you want to do mathematics. Um, if you click on this is a page containing simple examples of Python code, which I think is a sequence of programs that increase in length, I suppose. Um, let me, actually, this is not the code. Simple programs. Right. So here's a page of Python programs on the python.org website, where this is a one-line program, this is a two-line program, three-line program, etc., which is kind of nice. It sort of does more and more complicated things. It actually, the six-line program is already a bit more advanced. It uses something called regular expressions, which we don't need to learn here. In any case, so this may not be the most easy way to learn Python. Anyway, there's plenty of resources, plenty of courses. I'm just here to give you a rough overview. Let me close that. You can read more about it. If you want to install a local installation, do a local installation of Python on your computer, you can obviously go to this website and do Windows or Mac or other platform downloads and install them. Installation procedures are here. So you can do that. Let me show you what section installation looks like. So this is a terminal on this. I'm using a MacBook here. A Windows computer will also have this terminal program. It's kind of like a command line for your system as a whole. And let me just route myself to my folder. Let me do that. Oops. I'm doing tab complete here to complete these things. CD is change directory, as I'm sure many of you know. And then I have a folder called programs in MATLAB, but maybe I will just create a new directory, make new directory called programs in Python or something, and then change to that directory. Oops. Okay, and then if I say ls, which lists you the list of files, there are no files here, so I guess that's that. Anyway, so this is just an empty directory. I just routed myself to that directory just because I'm going to create some file there, a Python sort of program, and then run it later. I don't want to put the file any random place. So that's why I'm there. In any case, how do you open Python? I can just go Python 3 on at least my computer. And now I'm in Python. So set something, blah, blah, blah. It's Python 3.7.2. And looks like something about its version, I suppose. Okay, so we are now in Python, just like we might be in MATLAB's command line. This is the Python command line. You can install sort of a more graphic user interfacey version of Python as well. There are various things. One called Spyder, S-P-Y-D-E-R, Spyder. This is a sort of a nice graphic user interface, scientific Python development environment for Python, so it tries to emulate something like MATLAB. We can install that. Um, I think there is something called IPython, which is similar, which does similar stuff. In any case, okay. What else? Okay, I'm going to close this. I'm going to close this. So we are now inside Python. Let me just do a couple of random things here. Just like in MATLAB, you can just define variables. B equals 4, A equals 5, C equals A times B. We can do all that, okay? C equals A divided by B. C equals, well, notice that it doesn't actually say what C is. It just says, okay, and C equals A divided by B, or C divided by B. You can do that as well. And of course, if you want to know what C is, you can go print C. Apparently, that's what C is right now. If you want more information, you can go, let's see if it works. The value of C is, and then you can go comma C, and it does that, okay? The value of C is whatever. Okay, that's nice. What else do we want to do? We can compute the sine of C. Let's see if that works. It says it doesn't know what sine is. Name sine is not defined, okay? Unfortunately, unlike in MATLAB, Python does not have all the functions that you need already sort of accessible and loaded in sort of the default setting. So we will need to import various libraries that define these functions. So if you want to evaluate sine, cosine, tan, and so on, there's a library called NumPy, N-U-M-P-Y. You will notice that a lot of things, softwares, packages, toolboxes associated with Python have this word py associated with them, short for Python, of course. We already saw that. Spider had py. Anyway, so NumPy. So we've just imported that library, and then now all the functions that belong to that library now are accessible to us. So I think sine is one of them. So if you go numpy.sine and then C, okay, so we are saying I'm going to call the function sine that belongs to the library NumPy, okay? We can do cosine, tan, whatever. There's going to be a whole bunch of things. Rather than write NumPy sort of in long form, and some libraries might have even longer names, and you don't want to every time say NumPy dot, NumPy dot. People often say import NumPy as NP or something, where NP is just meant to be a short form for NumPy. It could be anything. It could be just be P. That doesn't matter, but people often use NP. And then you can go np.tan C and get the same answer, okay? And by default, it looks like Python does format long so that you see how many ever digits that you have, okay? Okay, so that's using Python in command line. Things can be a bit different, so let's see. Instead of if you do a power b as in MATLAB, something like this, it gives you 1. A is 5, b is 4, a caret, that element is called caret. Clearly, it's not doing the right thing. So if you actually want to do power, this is the operator for that. A star star b gives you 625, which is 5 power 4. Okay. Um, okay. Um, so what am I going to do next? I'm going to create a Python program and then try to run it. Um, Let me exit out of um, the Python command line here. Um, and then I'm going to go to MATLAB of all places. And I'm going to go into this folder called Programs in Python. It's an empty folder. And I'm just going to create a completely empty um, Python program called helloprogram.py. Okay. Um, this is the MATLAB editor, which I'm just using as a text editor. Okay. I'm just using it as a text editor. Uh, MATLAB programs are text files. Python programs are just text files. So you can use any text editor for doing that. If you're on Windows, you can use um, you can use uh, um, what am I thinking of? Notepad, for instance. But there's plenty of other softwares that will allow you to create um, Python programs or text programs, essentially text files. One of the ones that I use called Sublime Text. Here's a another software. Okay. In any case, we're just going to use MATLAB for now. And I'm going to write the simplest program here. I'm just going to say hello world. Okay, I'm just going to copy that and say that, and then go a equals 5, b equals 4, and then c equals 5 times 4, and then I'm going to say print 5 power 4 is space comma c, something like that. Okay, so what it should say is hello world 5 power 4 is whatever 625. That's all it needs to say. I just created the program now. We are in the folder here. If I say ls, which is short for list directory in command line, it says there's one file called helloprogram.py, which we just created. Okay. Okay, so let's run this. How do we run this code? There's a couple of ways of doing it. You can run it right in the command line. You don't have to actually go into Python. So if you go in command line, in the system command line, right, in your Windows or Mac or Linux, whatever command line, if you just go Python 3 hello program.py and say enter, it just runs the program and provides the output here. It says hello world 5 power 4 is 625. Notice that we are not inside Python. We are using Python to call to run this program, right? So this mode where you are sort of using the Python command line is called the interactive mode of Python, I believe. So if you go into the interactive mode, this is the Python command line. You can run the code by essentially importing it. Program.py. Let's see if py is necessary. Py doesn't want like the py. If you just go hello program, it didn't quite work. Let me exit out and come back in. I go import. Okay. So here's kind of a problem, which I'm not necessarily going to say how to fix it. So it turns out that if you import hello program inside inside the interactive board, it'll actually run it. Okay. But then if you do import hello program again, um, the next second time I do it, it will not run it. You can go out and come back in, or you can do some kind of a reset, which you can look up the syntax of how to do that online. Um, these are the kinds of things you should always look up. In any case, but if you just want to run it once, you go into the interactive mode and go import the program name, or just outside in the system command line, you can write hello program. Okay, so I'm just going to exit this mode. So that's basically how you write a Python program, run it, or work in Python in interactive mode. Um, so I'm going to skip all this, close the command line now for good, or at least for now. Um, and what I'm going to talk about next is using, I'm actually not, at least right now, going to have you all do a local installation of Python. You're welcome to do that. But we are going to use an online sort of implementation of Python called Google Colab, which is built on something called Jupyter Notebooks, or it's related to what's called Jupyter Notebooks. Um, so let me not go into what Jupyter Notebooks are, because I'll just talk about what Google Colab is. But Jupyter Notebook is sort of like that and came before Google Colab. Um, and you can certainly use Jupyter Notebooks as well if you have a local installation of Python. Um, let me close that. And notice that, by the way, Jupyter also has this py. um, okay, so so we are going to use Google Colab for this. Let me. Um, I think you may all have seen already a very short video, perhaps on Google Colab on YouTube, which I posted as an announcement. But what we will do is start afresh here. Um, just go Google Colab into uh, your Google search, and then click on that if you like. Um, so we can create a new notebook, or we can create, you can um, access one of the old notebooks, perhaps. Let me create a new notebook here. And this is what it looks like, okay? There are these two buttons, and the file name itself is called untitled0.ipynb. IPy stands for IPython. NB, I think, is a notebook. So it's not a pure sort of Python file.py. It's IPynb. I don't know, let's call this intro to Python or something, and Colab. And then let's give it November 2020 something. I just changed the file name. So this is actually going to be on your Google Drive. You will need access to your Google account to access this. Okay, so notice that this has code and text. So you can add code or add text. If you just want to add code, this is a sort of a code cell. I'm just going to say print hello world something. World called, no. um, okay, and if you want to run this piece of code, you just press this play button. It takes a little bit of time, but even though this simple thing takes a little bit of time, it turns out that Google Colab gives you access to large computational resources that might allow you to run very large pieces of code. Okay, so that works. This is the output. If you wanted to add more lines of code, we can just go plus. Well, we can do something similar to what we did. A equals 5, B equals, I don't know, 4, C equals A power B, oops. And we can say print um, A power B okay. And then if you want to run this piece of code, we can run it, okay? Says it runs these things and then 8 raised to the power B is 625. I do want to call attention to the fact that there are no semicolons at the end of these lines, unlike MATLAB. So you just terminate the sentences with, well, nothing, with just a carriage return, enter, which goes to the next line, okay? If you now wanted to add text, we can do that. We can add some text here, which is basically like writing comments. Hey, we are just writing some simple Python code. We can bold that, etc. Okay. And then we can continue with some code here if you want. Import NumPy. So here now it gives you a lot of options. It actually gives you this option, import NumPy as MP, because that's such a common thing that people do. And then we can just go d equals sign. I'm just going to say sign pi, okay, intentionally. It's going to give me an error. Okay, it says blah, blah, blah. The error is here on line 2, d equals sign pi. Name sign is not defined. Okay, let's do that. np.signPy. And then now we can run this again. Now it says name pi is not defined. Okay, so in MATLAB, if you just go pi, MATLAB understands it. Unfortunately, in Python, pi is defined inside this NumPy library. So np.numpy gives you d. So now it's happy. It didn't give us any answer. It didn't display any answer, but just computed it. If you wanted to display it, you can go d, I suppose. Okay. And that's the sign pi, I suppose. It's very, very close to 0. Of course, it really is 0, but in this case, it just happens to be super close to 0. Okay. So that's using Google Colab. Okay, so we can write Python code and you can run them step by step. It's sort of quite similar to running, defining MATLAB sections of code and running the sections step by step. So it's sort of similar to that. So that's Python, Google Colab. And very soon in the next video, we will walk through some more language constructs in Python.